Hi everyone, welcome to our third session this day. Today's talk will be led by Adam Wright. He is the Senior Product Manager at Enterprise DB. If you have any questions, comments, thoughts, please let us know in the chat box on Swapcard. Adam will happily answer all your questions after the talk. And there's nothing further more to say for me, and I'd say we dive right in to Adam's session.
Hello, my name is Adam Wright. I'm the product manager for containers and Kubernetes at EDB. This combination makes up our product offering, Cloud Native Postgres. Before working as a product manager at EDB, I spent many years as a database consultant working directly with customers using Postgres and as a principal consultant working on security analytics. The approach we are taking at EDB with our Cloud Native Postgres software for Kubernetes allows you to deploy the database in the same way you deploy application containers. For DevOps teams, this means bundling applications and their database backend together using the same standard tooling. So on the agenda today, we're going to talk about why PostgreSQL when considering running a database in Kubernetes, with the follow-on question, why EDB? We will also talk about the declarative management of our Kubernetes objects, the CNP cluster, and how this enables flexibility with your application. Future-proof your deployment by running a PostgreSQL cluster that can be deployed on private, public, and hybrid clouds with the same procedures. No need for operational runbooks depending on the location context. With CNP deployments, Kubernetes objects such as services are created automatically by the operator. And this really gives DevOps teams flexibilities to leverage all of the standbys of the cluster without having to have system DBAs vet and configure complex tools that have their own operational overhead. Along the same lines, we'll talk about some of the advanced features that can be leveraged for your applications without having to be a Postgres expert. Knowing Postgres always helps, but being a professional system DBA is not required. And finally, when you are ready to get started with Postgres and Kubernetes, how to get started with Cloud Native Postgres. So you're deploying applications with containers, and there are many different choices for where you store data. Let's first cover why EDB over the other options available. At the end of the day, what's being deployed is still Postgres. Whatever abstraction layers they may be, your data is still being stored and managed by Postgres. And EDB is the largest dedicated Postgres company with hundreds of technical staff dedicated to working on Postgres and working in the Postgres ecosystem. Not only can we patch the database server, but we can also develop advanced features our customer needs for running their applications in the database. And we also have dedicated support staff around the globe who have been working with customers that have been pushing the limits in terms of scalability with Postgres for many years now. And relevant to today's conversation, supporting customers who have been innovative in approaches to where the application gets deployed, and subsequently where Postgres gets deployed. All right, so you heard why EDB when it comes to Postgres. Now let's talk about EDB and Kubernetes. The core technology of Cloud Native Postgres is the Kubernetes operator from EDB. What does it take to be successful at developing a Kubernetes operator for PostgreSQL? You need a team of experts in both Postgres and Kubernetes. In EDB, we are heavily invested in Kubernetes. We are the first and currently only dedicated Postgres company to become a Kubernetes certified service provider. We have a large number of technical team members who are certified in Kubernetes. The Kubernetes expertise all complements the previous data points about Postgres expertise. EDB is also a silver member of the Cloud Native Computing Foundation. The Cloud Native development team at EDB performed 10 live demos in just 4 days at KubeCon Europe back in early May. If you're using OpenShift for your Kubernetes distribution, our operator, which is based on the primary standby architecture, is Red Hat certified for OpenShift. And when we re-release our BDR operator later in the year, we will do so only after achieving Red Hat certification. As we will talk about with continuous integration and continuous development practices in this presentation, you will see here at EDB that the Cloud Native team is leading with industry-leading modern development practices that you may be adopting yourself. In fact, we are releasing a new version of CNP every month. So if there's a feature your application needs, you likely won't need to wait long for the next version. So what makes up Cloud Native Postgres? What are we actually talking about here? So that the tangible components of Cloud Native Postgres are the Kubernetes operator with all of the expertise for deploying and managing the complex application that is Postgres high availability. And then, along with the operator, there are the operands, lightweight Docker container images for PostgreSQL and EDB Postgres Advanced. The same operator can manage both the database server types and different database versions. The only difference is the image name in your deployment manifest. And we begun adding tools to the Cloud Native Postgres suite. Prior to going in production, you can run CNP bench to validate a subset of the Kubernetes environment for database workloads. These are deployed as Helm charts and allow you to validate storage and database performance with standard tools FIO and PG Bench. We also have a plugin for kubectl that allows you to get cluster status results targeted towards CNP users without additional commands for performing various, and we've added additional commands that perform various actions, such as generating an SSL certificate for your application to database communication. And if you need to take operational actions, such as promoting a standby, you can do that with the kubectl CNP plugin. I'll show that in a demo here shortly. As far as the capabilities of Cloud Native Postgres, the main capabilities are to provide a platform that allows the entire lifecycle management of a Postgres database wherever your application needs to be deployed. Since Kubernetes is a de facto container orchestrator, we can use the same operational procedures, whether it be in the public cloud with Kubernetes distributions like Azure Kubernetes services, or in private clouds with Kubernetes services like OpenShift. We can use similar deployment techniques for those. And if you're using EDB Cloud Native Operator to deploy Postgres, there's zero lock-in. The operator takes standard Postgres backups using the open source tool Barman Cloud that are stored on an object store that you own and control. You define that in your cluster resource where those backups go. You own the backups. You can bootstrap a new Postgres cluster from that backup. So this all goes back, this all goes both ways. You can bootstrap a new cluster from CNP using that backup. If you want to restore that backup to a virtual machine or bare metal that you own, all you need is the same PostgreSQL version that you took the backup with. And Barman Cloud, which again is an open source tool. So additionally, what makes EDB unique? So using the Kubernetes operator by EDB, you can run PostgreSQL, the open source community database that EDB is a major contributor to. You can also run EDB Postgres Advanced. And if you have a need for production grade bidirectional replication, where all nodes in the cluster accept writes, where promotions of a standby aren't required when doing a failover, then later in the year, you can use the BDR operator that's being re-released by EDB. These are all technologies developed within EDB for open source tools. These are tools that are maintained by EDB. And the HA components are baked into the operator itself, and those are designed and written by EDB staff. So we didn't have to go hunting around GitHub, looking for a project that has backups, looking for a project that has HA, and try to glue them together with an operator. These are EDB developed and maintained technologies. So at the end of the day, you get Postgres expertise, you get Kubernetes expertise with Cloud Native Postgres. While the operator is opinionated, you have flexibility with which EDB technologies best fit your use case. All right. We're going to further make the case for why Postgres is a great database platform for developers, why Postgres is a great platform for DevOps practitioners. If you're on this webinar, you must be at least considering it. But let's get into the deployment specifics and its impact on app development and DevOps teams. We'll do a demo. Let's talk about declarative cluster configuration. So Cloud Native Postgres, which is a product entirely written in Golang, just like Kubernetes, it's fully integrated with the Kubernetes API server. So it relies solely on Kubernetes to manage high availability. So we didn't use tools that were intended for traditional context. And we build immutable application containers for PostgreSQL 10 and higher and EDB Postgres Advanced 10 and higher. So what does that mean? Once you hand your application off to the DevOps team, the team doesn't then need to write their own procedures on how to apply a security patch or how to update PostgreSQL. So if the application is Postgres, or your application needs Postgres, then those operational tasks are going to be managed by the operator. So no more standard operating procedures that you need to test, validate, and write yourself. If a rolling restart of the cluster is required, the operator is going to schedule and perform that rolling restart. If there's a switch over the primary that's required, the operator is going to perform that switch over. So instead of updating software in place, the operator essentially replaces the container and reattaches PG data. This is a big paradigm shift. As a hardening exercise, we've gone as far as implementing root-only file system for pods. We've also run by default with a restricted SCCC if you are running Cloud Native Postgres in OpenShift. And if you want to develop your application on a production-like environment or need to troubleshoot on a copy of the database that's like production, you can do all that even from Docker Desktop with software like Kubernetes and Docker. The deployment is essentially the same. So likely with your application deployments, you might declare that you want 3 web servers and 2 application servers. Since your web servers don't store state, Kubernetes can natively handle the job of ensuring that the actual state meets the desired state. The web server goes down, the operator detects that, and it's just going to restart that pod. But with a complex application like Postgres, deployment and management requires injecting application expertise into the Kubernetes controller. And when we do the deployment, we want to follow an imperative mindset. So with the imperative mindset, you would say, create a replica, configure the replica, create a primary, configure the primary for replication. Clone the primary, set it as a replica, clone a third one, set it as a replica. Kubernetes doesn't know Postgres. So what we have here is a bit like the instructions for baking a chocolate cake. Drive to the store, buy baking pans, buy flour, buy cocoa powder, drive home, preheat the oven, so on, until you pull the cake out of the oven and have what you want. The Cloud Native Postgres operator is designed for Kubernetes and manages state. Therefore, we define the cluster through the declarative configuration. Using the chocolate cake analogy, we simply order chocolate cake. For PostgreSQL, we say instances : 3, and the operator gives us a PostgreSQL primary with 2 replicas. So in the declarative approach, the state of the system is defined in your CR. And we're in a couple of slides, we're going to get to a really helpful visual of this, and then we'll also do a demo here in just a minute. So states in Kubernetes. So the primary goes down, the operator performs a switchover and brings back a new standby. We didn't change the desired state, and we're relying on Kubernetes reconcile loops. All right, so my cluster resource, we say the desired state, instances:3. Now we're going to initialize a new cluster and run initdb. And here's my primary with read write. We said instances:3. So now we're going to initialize a second pod and configure that pod as a replica. The operator is then going to initialize a third pod, and it's going to follow the primary. If something happens, a Kubernetes worker node dies, a pod dies, whatever the case may be, the operator is going to detect that, either try to heal that pod or create a new one, whatever. So the desired state didn't match the actual state, and so the operator took action. If something happens to the primary, this is where the Postgres expertise comes in, the operator is going to promote the second replica or the most up-to-date replica. And since our desired state is still 3, the operator is then going to either try to recover the primary and bring it back to the standby or create a new pod and new container. We can scale the cluster up. We can scale the cluster down. So we have a read-heavy workload. It's a busy weekend. Maybe it's a holiday weekend. We can do instances:4, post our change to the Kubernetes API server, and now we're going to have 3 replicas. And the weekend's over. Let's scale back. Let's scale down to 2. Now our actual state and our desired state match. So we adopted the convention over configuration paradigm. So the YAML file that is on this slide, this is sufficient to create a cluster with a primary and 2 standbys. That's all that's needed. So this is going to give us a cluster with the logical name MyAppDB, 1 primary, 2 standbys, looking at the number of instances. And then our image name, we pulled from Key.io, Enterprise DB, PostgreSQL. This is going to give us major version 13, minor version .13, and then the dash is for our UBI base image update. And then our PG data size is 10 GB. So kubectl apply. These 2 commands are all that you need to deploy a new cluster. So you can see how easy this would be to put CNP into your CI/CD pipeline. You get into backup and restores. Let's pull a Go copy of our database down and run our application test against that. Really easy to do. And you can package these up with Helm charts with your application. The possibilities are endless. As you'll see later on, we do this within EDB, deploy new clusters, deploy new operators multiple times a day. So let's take a look and see how that works with a demo. All right, so I'm pulling up my terminal now. Just going to clear the screen, make sure I don't have anything running. Okay, so I have no clusters running at the moment. Let's go ahead and look at my deployment configuration. Sorry, typo. Okay, there we go. All right, so the logical name of our cluster, PGHA Dolores. Our image name, we're pulling this from Key.io, just like before, PostgreSQL 13. It's the major version, minor version 3. And then our UBI update is 8. So every night within our CI/CD pipeline, what do? We check, is there a new minor version of PostgreSQL available? Is there a UBI base image update available? If any of those 2 are true, then we're going to build new container images. So you can pull the minor update and the security updates in one, or if there's only security updates, then just pull the security updates. This is just running on my local system, so I'm just doing just 1 primary by default with just 1 GB for 1 gigabyte for my PG data directory. I've got some custom PostgreSQL parameters and my initdb parameters as well. These are completely optional. And then database is Shogun world, owner is Maeve. These are optional as well, but if you want to specify a new database, a new user that owns that database, and set the user password with your cluster deployment, then you can easily do this. So create database Shogun world, owned by Maeve, set Maeve's password to this secret here. So whatever password I have set the secret, that is what Maeve's password is going to be set to. So let's go ahead and apply this cluster. All right, so I posted my change to the Kubernetes API server. And then we talked earlier about the kubectl plugin. For right now, we're just going to use the standard tooling. So get cluster, and then you could see here my options that are available. These are the parameters changes that we made, image name, the PostgreSQL parameters that are being managed by the operator, certificates that were created, the Kubernetes service objects that were created. And now let's just go ahead and see the cluster from the point of view when we use the CNP plugin. So some of the same information here, clusters in a healthy state. So the instances 1 and the ready instances match. Our container image name, our primary instance, managed parameters, our PGHBA rules, host-based access rules. And then we have our replication status here toward the bottom that's formatted towards CNP users. So right now we only have one primary, but it shows our logical sequence number. And then if we had standbys, it would show the logical sequence number for those both received and replayed. So let's just go ahead and look at Postgres. And we'll run PSQL, see the list of users, and so the list of databases and describe users. Right, so we have our Shogun role database, and we have our application user, Maeve, that owns that database. And we're going to go ahead and check the server version number. So select version function from Postgres, and we're running PostgreSQL 13.3. Now, I just happen to know that there is a newer version of Postgres available. 13.4 is the latest. And there's also UBI updates available as well. So let's just go ahead and change our resource on the fly. 4-4. All right, make sure I don't have any typos there. 13.3-8, 13.4.4. All right, let's post our change. And now let's check the status. Okay, upgrading cluster. The primary instance needs to be restarted. Reason, the instance is using an old image name. And we can see the new image name that's going to be used in our cluster. And now we can see 13.4-4. And since that contains a updated version of PostgreSQL, let's go ahead and check the version. And now we can see our cluster is running PostgreSQL 13.4. And if we wanted to do something a little bit more advanced, we could, let's go ahead and keep the image name, that way we don't overwrite that. We'll change instances. We'll add a replica to our cluster. So we can add this replica on the fly. Instances, :1, instances, :2. All right, we post our change to the Kubernetes API server. Let's check the status. And we can see our status, creating a new replica, PGHBA Dolores, or bootstrapping a new cluster, bootstrapping a new pod to the cluster. And all right, so now we have a replica. So we're running in HA mode now. So our primary and our standby, our desired state, and our actual state match. All right, so I'm just going to go ahead and delete the cluster. All right, and we'll bring up a new cluster in another demo later. All right, so let's go back. All right, so this is exactly what we did, right? I had created the operator before recording this video, but it is literally one command. And then we deployed a Postgres cluster with the operator using a single command. All right, so PostgreSQL and Kubernetes. Sorry, one second. All right, sorry, switch sides. All right, now let's go ahead and talk about more specifically, why Postgres itself as a database for Kubernetes beyond just the operational aspects. All right, so the first question to ask is, is PostgreSQL a good fit for Kubernetes? Well, PostgreSQL doesn't try to be a operating system in itself like some other commercial database systems, that were developed heavily during a different era. So Postgres has a long history, but we're relying, runs more lightweight, and we also are leveraging features that are available on the operating system. So for developers, Postgres has a rich set of data types, and it is performant. So the database workload is Kubernetes friendly. So it's lightweight. You're doing microservices. You have a rich set of different data types that you can choose from. If you're using ORMs, it's supported by the most common ones. And you have flexibility for development practices. You have flexibility for deployment practices. So that gets into how much operations workload is acceptable. So if you need flexibility in operations, you want to manage some aspect of the operations yourself, then Cloud Native Postgres is a good fit. If you don't want to manage any operational aspects of running a database, then a DBaaS like EDB Big Animal could be a better fit. If you have a large monolithic application, you're not embracing microservices, you do have a heavy operations team, large team of system DBAs, need to do low-level Linux kernel tuning, have your own database installation and maintenance tasks, then you still have the option to deploy on VMs, still have the option to deploy on bare metal. But hopefully this helps to show that Cloud Native Postgres, you are considering Kubernetes, why it's a good fit. It makes the case for it being a good fit. So PostgreSQL has a rich set of data types to choose from. So this makes it extremely easy for developers to enforce business rules. We bring this up because a lot of customers on their journey to databases on Kubernetes start to explore whether to use specialty database systems or stick with a relational database when developing new applications. So you might look at whether or not to use a document database. Well, you have that choice in Postgres. Now, there are elementary data types like character with fixed length or padded, text for variable length characters. You can perform explicit typecasting in your applications or in Postgres server-side functions. There's several choices for storing numbers and ranges and integer values, and these allow you to perfectly match the numeric type to the business attribute being applied. And there are more specialty types for applying business rules. Boolean for true, false, on, off, and those can be represented in different ways. Arrays, byte A for binary data, XML, JSON for document type, HStore for key value pair, money, IP addresses, IPv4, IPv6, MAC addresses, and many more. And through the extension framework of Postgres, specialty database data types like PostGIS are available. And then you can also, develop your own, custom business rules for data types if you want to get into that area. So you might have a specialty data type that is special to your industry. You could develop that through the extension framework if you wanted to. All right. So along with specialty databases systems nowadays that are commonplace, a lot of NoSQL solutions out there. So you might be looking at, do we want to use document storage? Do we want to use a relational databases? But one of the powers of Postgres is that you have the choice of whether to do all document. So this would be creating a table that stores nothing but JSON-B as the document format, or something like HStore for key value pairs. And then you also have the option for semi-flexible data, semi-structured data models that you can easily evolve with application needs. So if you look at the all document orange, there's a single column that has a JSON-B document, all relational where you have foreign key relationship, business rules applied to different column types. And then you have a mix of document relational, that allows you to enforce some business rules, but it also allows your schema to evolve. But with Cloud Native Postgres, you deploy where you need to. And with PostgreSQL, you design the data model for your application. There's no need to force a choice of document versus non-document because of the platform decision you made. Postgres foreign data wrappers. So once you've taken a monolithic application and broken it down into microservices, these services might be small, but you still might have, a lot of data, and you need to communicate efficiently. So you don't want to pull a lot of data down into your application and do filtering that way. That's kind of going well before the days of, SQL with a lot of proprietary databases. You can communicate efficiently on the back end, via Postgres foreign data wrappers. You add that to something like Kubernetes services that Cloud Native Postgres creates that you can define in your PostgreSQL foreign data wrapper definition. And then you can start easily communicating on the back end. So you get join, predicate, aggregate, push downs, query optimizations, things like that you wouldn't get in your application without having to write your own, basically, database code in the application. And like we mentioned, what makes the Kubernetes operator from EDB unique? Well, if you have an Oracle background or you're migrating an application written for Oracle, you can optionally choose to use Advanced Server. So these aren't just catalog views, although there are those all DB and user, but advanced features in Advanced Server are some of those, just for example, advanced queuing, Pragma autonomous transactions, interval partitioning, hierarchical queries. So you get a lot of very strong Oracle features within EDB Postgres Advanced. And so if you're doing new application development, PostgreSQL, you've done some migrations with EDB Postgres Advanced, you can still use Cloud Native Postgres to deploy either of those workloads. It's just the image name in your cluster CR that's going to be different. So the ability to deploy on both private and public clouds is becoming a key requirement for new application development. So let's talk a little bit about how CNP allows you to deploy anywhere, leveraging the declarative configuration we talked about earlier. So we've established, one of the key characteristics of cloud native application, you should be able to run it anywhere, including on premises. So today you might have an application requirement to run in your own data center. Tomorrow, the business might need to expand to a separate geographic area with a public cloud provider. Well, with Cloud Native Postgres, you'll be using the same operator and the same container images. And backups, these are standard PostgreSQL backups that you own in your own storage location. The backups are tightly coupled with a deployment, and they're defined in your deployment. So the same configuration will run on any Kubernetes hosted on different cloud platforms, and this mitigates the risk of vendor lock-in. So can Cloud Native Postgres be deployed anywhere? And what does EDB actually know about this? Well, with Cloud Native Postgres, we try to build quality directly into into the product. So this all starts with a get workflow and actions that execute automated tests and static code analysis through linters. And then we try to shift left in the area of security. We have a multidisciplinary team that does include security and administrators. And the role of Kubernetes in the end-to-end test is critical. So we spin up Kubernetes clusters, first using Kind, and then we use the different Kubernetes distributions we support and run deeper tests. And so with those tests, every different combination of Kubernetes distributions we support and the different database types that we support, like PostgreSQL and Advanced Server, in each of those versions are tested against each Kubernetes distribution. So a full suite of tests is run for every single release that we put out. And this is a simplified model of the process that Cloud Native Postgres development team has adopted and been using for several years now, with many different iterations and improvements over the years. All right, so in your own development practice as a DevOps practitioner, can you use Cloud Native Postgres to run QA/QC checks? Well, absolutely. You can easily spin up a new Kubernetes cluster programmatically. You can deploy the operator, perform a new database initialization, and then a schema deployment. You might have a goal copy of an application, a goal backup of that application in an object store within your CI/CD pipeline. You can pull that down, run tests against that cluster that has been bootstrapped with a goal copy of your application. So that this is all easy to do. So you can run a series of tests on a production-like system without actually affecting the running system. In fact, you could bootstrap a new cluster from the running cluster. So you need to test something out. It's mission critical. It needs to be just like production. You could bootstrap a new cluster from your running cluster if you chose to. All right, so a little bit more about the end-to-end test that we perform. We test on, like I mentioned, we test on every Kubernetes distribution that we support, or the different versions that we support, all the combinations of database servers. We have over 100 tests that we run, some of the relevant ones, installation and creation of a new cluster, scale up and scale down of a cluster, failover, switch over, and continuous backup and recovery. And as part of a cluster deployment, we generate Kubernetes service objects. This is a critical component of the deployment, is intended to be the endpoints applications connect to. So with the PostgreSQL architecture that implements primary standby, we create a service, and read writes are directed at the primary. Reads are for read workloads that would go to each, and then the read-only suffix would route connections only to the replicas. So these are created automatically by the CNP, and these are reliable DNS endpoints for your application. If you're running Kubernetes, you can expect there's going to be some network churn. So this addresses both the issue of your applications being able to leverage those other replicas, and also not having to make changes to your application when there is churn in the cluster. So IPs for containers and pods are going to change. This gives you a reliable endpoint. If you always want to point at the primary, then here's the DNS endpoint. And if there's churn in the cluster, doesn't matter. The Kubernetes is still going to route that to the correct pod. All right, so here's a visual of that. So this is the RW service that's created automatically with the cluster. And as you can see, once you point to that DNS endpoint, your connection is always going to go to the primary. And another one that points to all the read servers for read workloads. And then we're also working on a read-only service that would just connect to these two light boxes here. So the PostgreSQL standbys. Here's another visual. So on the top left box, we have our deployment manifest with a logical cluster name, PGHA Dolores, and instances 3. This manifest gives us one primary, 2 hot standbys. Once we create the cluster, then we're going to have a list of services here that are created automatically. And no matter what happens in the cluster, the services will always route to the appropriate Kubernetes pod. All right, so in terms of architecture, there are two main architectures, based on where the application resides, inside Kubernetes or outside Kubernetes. The first one is going to be the best experience for Cloud Native Postgres, and that's everything running in Kubernetes. But there might be legacy applications outside of Kubernetes. You might have analysts that have a desktop application, and they still need to connect to the database server. Lots of different workload types that need to be accounted for. In that case, you can create routes, expose that port to the outside world if you need to. We support both. And so this diagram gives a little bit more detailed of the components of applications in databases and Kubernetes. So the application is going to perform rolling upgrades, probably going to be a replica set for scaling and high availability, custom applications, Go, Java, and the like. And then the stateful database component is the database that's managed by our operator. And then when you're ready to connect to a service, then your application, here's a simple example, a const block in Go. This would be similar in other applications such as JDBC, where you have a JDBC URL, and you include the correct DNS endpoint for that service. So username, password, and databases can all be managed as part of the application deployment, and then you can put that in your application code as well. If you have parts of your application that are only reads, then you would have another class that defines the read service, and in your application, you would use that class in different parts of your application to leverage all the other clusters in all the other instances in your Postgres cluster. All right, so there are advanced features of PostgreSQL that are typically reserved for companies that have staff with Postgres expertise. These features are either happen transparently or a part of the deployment manifest to be managed by the operator. The point being, you don't have to have deep Postgres DBA expertise to be able to leverage those features when you're using Cloud Native Postgres. So default PGHBA settings. So this allows you to control who and how applications connect to PostgreSQL. You just define this in your deployment manifest. Synchronous replication. So if you need to ensure that, hey, if I get a commit successful message back for my application, that change record was actually received by another standby, so no lost in flight transactions that received a commit message, then you can configure streaming replication with Synchronous with just 2 parameters. And for your PostgreSQL parameters, this is really nice if you have a change management system with your deployment manifest, and then you're reapplying the configuration, reposting that configuration. This can all be just defined in your deployment. So using this workmems in the slide here, so if you run into an explain plan and you see an external disk merge message, you can simply update the deployment manifest. Hey, this container has a lot of excess memory. We're just going to set workmem at the cluster level and post that change, and you should see fewer queries spilling over to disk. And another nice thing about updating the parameters in your deployment manifest is that it can be self-documented. So you can ensure that all your changes are pushed to a central repository and apply the manifest over an HTTPS connection in your code repository. The operator automatically detects the version of PostgreSQL you are running, including EDB PostgreSQL Advanced. All you need to do is point to an official EDB Postgres Advanced image. All right, so now we're going to get into a short demo here. I talked about, you could still expose ports to other use cases in your business, like you might have a desktop application that needs to connect to a database running in Kubernetes. So let's take a look here. So I go back. All right, make sure we deleted our pods. Just make sure our deployment is gone. And let's go ahead and look at another deployment here. All right, so the only difference here from our previous cluster is that we're using a different image. So in this image, you can see that we have -Postgres. So our image here has the Postgres extension enable, the Postgres extension available within the container. The reason this is a separate image is because Postgres is quite a large deployment. But if you happen to deploy without Postgres and you need it later on, you can just update the image. So you can update your desired state to have Postgres, restart the cluster, and then Postgres will be available for you. All right, so I'm going to go ahead and do a deployment. And let's see here. We see our services. So these are the services I was referring to in the slides earlier. And I'm going to go ahead and expose the port. This process would be different in production, but this will go ahead and make the point. Our port is 5432 for PostgreSQL. So service pghj Dolores-RW. All right. And let's just go ahead and double check before I pull up a desktop application that I can connect. And I know what my password is for the secret. Okay, there we go. Got no extensions installed at the moment. Let's go ahead and do that the long way. Going to create my Postgres extension. Create extension Postgres. All right, got a typo. All right, there we go. All right, so now Postgres extension has been created in our database application database Shogun world. Let's go ahead and make a little room here. We're going to use the shape to PGSQL application. This is installed locally. I'm going to use SRID 4326, and I have a shape file installed or downloaded. This is from the Census Bureau. This is US states, 500K. And our application user is Maeve, and our database is Shogun World. All right, so we just created a new table for US states, and it has the Postgres geometry type. Now let's go ahead and open up pgadmin 4. All right. And it looks like I have a previous connection here. Okay, I need to get the super user password. I have a shortcut for that, get super user password. All right, now I'm connected to my database that is running in Kubernetes. And you can see here tables, Census Bureau 2020, US states, and 500K. So let's go ahead and query the data. Just gonna fetch all rows here. And this could be any application that you have. It's taking a little bit to return data. And we'll pull that all the way over to our geometry viewer. The last column is a geometry type. And you just get a visual here of the US states on top of an OpenStreetMap space map. All right, so that's just a short example of, if you can deploy Cloud Native Postgres, create an application user, you can expose ports, and then those applications can still be accessible, whether the application is in Kubernetes or even on some use cases where you might have a desktop application still. All right, so let's get back to our slides here. All right, so recommended next steps. The EDB docs, so if you go to enterprisedb.com, resources, docs, there is rich documentation here. I say rich because all of the features that we talked about are documented in detail. You can also go through an interactive demo. Every month, you're going to see a new version. That's our current release cycle. So I very encourage you, if you are interested in Cloud Native Postgres, to visit the EDB docs website. Trial guidance. So currently, the operator will allow you to deploy PostgreSQL. No issues. After 30 days, you need to apply a license key. You can download a license key from the website. Go to the Kubernetes section under products. If you're going to deploy with EDB Postgres Advanced, need to get a license key that will run for 60 days. What happens after that expiration date is has been exceeded, then the cluster will continue to run, but no reconciliation will have to happen after that point. You get a license key, you just simply apply that to just post the license key to the Kubernetes API server, and it'll be applied to the running deployment. All right, so I recommend go to the EDB docs website. You can do the interactive demo, deploy it locally, and contact EDB, and we can help you be successful deploying Postgres and Kubernetes. Thank you very much.
Thank you, Adam. We now have time for a few questions. If there are any questions, thoughts, comments, Adam is here with us. He's happy to answer anything. Thank you again, Adam, for your talk. As of right now, we don't have any questions. I'll wait another few seconds before I close this talk, because the presentation was a bit longer. We have to cut the Q&A a bit shorter. Let me check.
Sounds good. They can, if anybody has any questions, they can come to the EDB booth later. Yeah,
okay.
I'll be happy to talk with them.
Perfect. I happily take that offer and close the session because it was a bit longer, the talk, than expected. So if anyone has any questions or wants to know anything, wants to have more information, EDB is happy to answer everything. Adam is happy to answer everything. And thanks again for your talk, and thanks again for everyone participating. And now I hope you all have a good lunch break.